Thank you, Rainer. So actually, thank you for the introduction, so I don't have to do it myself. I'm working as head of engineering at the company MicroControl, and as Rainer already mentioned, I'm working in various CiA special interest groups since, I guess, 25 years already, and have developed some of these specs, or added part of these specs. So what's my agenda for today concerning this presentation with the title CAN-based control networks in mobile machines? First of all, I would like to look in some of these application-specific CAN protocols that Holger has already mentioned. Then we are looking a little bit in the CAN Open in mobile machines. I will focus on J1939 in mobile machines. And in the end, I will have a look on the combination of those both, CAN Open and J1939 in those machines. So just in case, if you're wondering why you see this picture there beside my agenda concerning a grill with a lot of sausages, the reason why I've selected this picture is because CAN-based control networks in mobile machines is, from my point of view, a little bit like German sausages. You know that there is somehow meat inside these sausages, but you don't really know what meat is inside these sausages and what has been mixed inside. And sometimes you really don't want to know this for sure, but you like the taste. And you see there are different kind of sausages, and that is exactly what we have when we're looking into CAN in mobile machines. So first of all, what already has been mentioned also by Holger is, let's say, the top of the iceberg, the easy part. So if you have a mobile application like a firefighting truck, then you're already done. You don't have to, let's say, get into details of various specifications, because there is a specification already there for you called FireCAN, or the official specification name is the DIN 14700 from 2025. That's the newest, the latest one. The good news for all these CAN Open fellows is it's based on CAN Open, but it's not real CAN Open. It has some slight modifications in that. For example, it uses some predefined PDOs. What it does, what it helps for these implementers of these firefighting trucks is you already know how to connect a water pump, a mobile light, and all these kinds of tools, let's say in general tools that you need for firefighting. You have a standardized interface and it works out of the box with this firefighting truck. So maybe later on, I don't know, Holger also tells us some more on FireCAN. The next topic for mobile machines, which is where you can say everything is already done and prepared for you, is the headline of municipal vehicles, so waste collection. It is specified in the Clean Open standard. Also, Holger has already mentioned that. That's the CiA 422 profile. Also based actually on CAN Open, classic CAN Open. It is designed in that way that you can have up to 8 logical networks which can be used individually for bin classification, for the lifting, for weighing, compaction, and all these kinds of stuff which are necessary to set up such a mobile application. This profile again uses so-called predefined PDOs and also predefined SDOs for CAN Open communication, so that it makes it very, very simple also for third-party manufacturers to set up devices which can be sold to companies building such kinds of trucks. So it's a really plug-and-play solution. But let's get back to the question, why do we have these multiple CAN protocols in machines? I selected here the picture of a straddle carrier, not for a specific purpose. I could have taken any other mobile machinery as well, because what we often find is that we have different CAN networks in there running different protocols. So typically, here in that straddle carrier, we have a diesel engine which runs with J1939. We have remote IOs there which run with CanOpen. We have a spreader which runs hopefully with CanOpen, and we have some electric drives or other parts which run with CAN à la surprise, or however you would call it. When I talk to customers or potential customers and say, hi, why are you using your own CAN protocol? Then sometimes the answer is because we buy these parts from vendors who are not aware that they are standards. But in most cases, I get the feedback, this is a company-driven standard. We do that for more than 20 years. And we have all developers here, and they engineered it over the years, and we are fine with that. And right now, they're coming to Canon Automation or to us and asking, maybe we can switch over to CanOpen or J1939 because we see that these old developers are going into retirement, and CAN à la surprise is not suitable anymore. So just in case, if you are one of those who are still using CAN à la surprise, maybe it makes sense to think over to getting to a standard like J1939 or CanOpen. Let's switch over to what can be used for CanOpen in mobile machines. I don't want to stick to all these different kind of device profiles and application profiles. I just want to give you two examples. Here the picture, that's a picture I made on the latest Bauma fair. It's the Liebherr T264 vehicle. It's a totally battery-driven car, and it's running internally also with a CanOpen network for measurement of sensor data. So what we can offer from the CanOpen point of view, for example, for road construction and earth moving machines, is the CiA profile CiA 415. That has been designed to connect sensors to a CAN bus, to a machinery, and up to 126 different sensor units. It provides an interface to the CiA 436-4 standard for sensor systems. We will see that later. So you have typically a sensor controller running there, and typical sensor data examples are machine speed, steering angle, material volume and mass, environmental conditions. So you can find anything there you want for your mobile application. And just in case, just to mention it, if you don't find it there, your sensor data, then just send a request to the Canon Automation, and we set it up there. We can extend that. The next possible standard for this construction machine control system is the 436-1 standard, also something that already Holger has mentioned. And this is the standard which is, let's say, a kind of the backbone. You see here again this sensor control and the connection to the CiA 415 system. And here we have got possibilities to connect fleet management, generic implement controllers, an engine controller, transmission system, specific implements, the interface system to the driver. So you have got all options here in order to connect the machine control system here based on CanOpen, on CAN, on a standard system. Let's get back, and that's what I already mentioned, that's my focus. Let's get back to J1939, the other standard in mobile machines. And here I get back to my picture of sausages, and sometimes the reason why you taste the sausage and you say, it looks like a sausage, it feels like a sausage, but it doesn't taste like a sausage. What did I get? And that is sometimes pretty much the same when I'm talking about to customers to J1939. It looks like J1939, but in real it isn't. And let's get a little bit in the details why it is in that way. The SAE provides several specifications. I have listed some of them here. Besides the introduction, there is some specifications concerning physical layer. There is the J1939-21, which is the data link layer, but the title is not so correct. It doesn't also tell you the data link layer. It also tells you something about the protocol which is running there. So whenever you want to deal with J1939, please be aware to get this standard. And in addition to that, what is very important for you as manufacturers maybe of mobile machines is also the so-called digital annex, because the digital annex, the J1939-71/DA, describes and defines all these signals running there, and all these signals, they have a certain number which is called SPN, I come later to that, which are grouped together in a parameter group which are assigned to a parameter group number. So this is very important. Why do I say that? Because I often have get a feedback when I do trainings at a customer side, and I say, okay, you're running J1939, have you looked into the standard? And I say, we don't have the standard here. Oh, that's a surprise. So you're running a standard, or you're running, you're, let's say in a sausage way, you're building sausages, but you don't have a recipe how to make a sausage. That's a little bit of a problem. So just in case you want to run J1939, maybe it makes sense to get the last two pieces mentioned here of these specifications. And let's get a little bit more into the details, and I want to focus on the topic why I think that J1939 is suited for only parts of the control system in a mobile machinery, but not for everything. And I'm saying that because I'm often in the situation that people tell me, we're using J1939 for the winch, we are using J1939 for these kinds of sensor or actuator, and how do we have to do that? Can you give us an advice? And my feedback is typically, no, I can't, you're lost in space. The reason for that is, if we are looking into the CAN protocol, into the J1939 protocol, what they are doing is they are putting all these, let's say, protocol kind of information into the identifier, and they are using a 29-bit identifier, which consists of this first 11-bit part and the 18-bit part afterwards after the IDE bit. So we have a 29-bit of identifier. We don't look into the data now. We are only looking into this identifier. What they have done within the CiA and with J1939 protocol, is the following. They split this identifier up in several parts. And whenever you wanted to know what is this so-called PGN, and you never wanted to ask for, I tell you now, this PGN is a so-called parameter group number, and it's the middle part of the identifier. And this middle part of this identifier, this parameter group number, is very important later on for your old protocol and for everything you are setting up. It consists of two 8-bit values and two single bits, these EDP and DP bits. We don't care for these bits, we only care now for these two sections which are called PDO format and PDO specific. So these 18 bits, they setting up this parameter group number. So whenever they do something here, the very important stuff is the so-called PDO format, the let's say middle place of the identifier. And this one is split in two areas. So you can have values in these 8-bit values, value of 0 to 225, and they split it up into an area from 0 to 239 and from 240 to 255. And they give them different names. The first one is the so-called PDO1 format. The second one is the so-called PDO2 format. And this format field defines the field afterwards, the PDO specific field. What they are doing there is, if we have a PDO1 format with values between 0 and 239, the second field is the destination address. So we are doing here with this kind of protocol, we are doing a point-to-point protocol. And they were thinking, when they were starting this kind of design, it might happen that later on the data that we don't see, we have to define it somewhere in the specification. We missed something, or we are not aware of customer-specific applications. We have to do something to avoid a deadlock. So we give customers the possibility to add proprietary data. So they did so, and they put in the specification, if the value there is 239 in decimal, we have a proprietary A message. So we can extend that, of course, via our two single bits, EDP and DP. So the total number of parameter group numbers is 4 times 240, which means we have 960 different values for a PGM. Pretty much the same happens if we look to PDO2 format, where here the PS field is a so-called group extension, which is meant to be, the whole protocol is intended to run broadcast data. Here again, the idea is to give the customers the possibility to run everything over proprietary data, and they call it proprietary B. With this proprietary B, you not only have one possible, but you can have 4 times 255 because you have the group extensions. So you as a customer have 1024 possibilities to do your own stuff. So the total number of PGNs is 16,384. And now I come to the point why I think it is a little bit a problem to use J9039 for everything. Because although you have 29-bit identifiers, the old stuff allows you only to have in total 17,344 PGNs, which is a limitation. Now, coming back to my introduction about J9039, when you have a winch or something else, and you look into that and say, hey, where's the data for the winch? You won't find that in the digital annex. So what do you do, or does your vendor of the winch do? They putting the data into proprietary information. And they can put it in, different vendors can put it in different ways into this proprietary data. And that leads to problems, to real integration problems. Another impact of J9039 is if you want to send big amounts of data, there's a limitation up to 1,785 bytes. That's the limitation. You can't overcome that so easily because you're sticking to their transport protocol. The next problem that you have is with J9039 is when you do proprietary stuff is the limitation on possible data types. There are only 3 of them: 8-bit, 16-bit, 32-bit, and everything is unsigned. So how they do that? They're doing it in that way that they're putting these variables, these signals together, have a certain number for their signals, and give every signal a formula where they say what is the resolution of that signal and what is the offset. So you have to know from this digital annex every signal precisely to know the resolution and the offset. And this is another headache for you as an end customer, because you can't simply buy a sensor, for example, for pressure, because there are more than 70 signals for pressure, and they all have a different resolution and a different offset. So if you place a sensor, a pressure sensor, which is intended for the engine somewhere else, you get totally other values that you're not expecting. So the point is, if you're working with J9039 on the powertrain, everything is okay, and if you find all your signals and PGN in there. But if you don't find your signals within the digital annex and you want to extend your machinery, you have a little problem, because you have to stick also to their definition of SPM value ranges, which are different for 1 byte, 2 bytes, and 4 bytes. And I know by experience that vendors which provide J9039 in a way that they implement it in a proprietary way, they don't stick to this. This leads to problems during your integration. And this leads to funny things like people using CanDB files in order to get to integrate some specific sensor which are running with J1939. Here's an example here for engine speed, how it works with J1939, just to show you, if you stick to the standard, everything is fine. But if you leave the standard, if you leave the powertrain a little bit to the left or to the right, you're running into a problem. Also, what Holger has already mentioned is the MIG 4.0 standard, which has been now introduced during the Bauma. It is specifically designed for excavator applications, and you can stack up to 3 working tools to your excavator. The problem here, again, that I see is when I look to the specification, everything has been done via proprietary PGNs. So I was told there on the fair that this is just a single CAN bus and it's just for the tool of the excavator. But if somebody else within his excavator wants to add something else to this specific bus, which is using the same proprietary PGNs, then you're running into deep problems. So using proprietary PGNs with J1939, from my point of view, is a nightmare. Let's get over and try to combine something. So let's combine some sausages with some pieces of meat, and let's try to combine CANopen with J1939. What options do we have in order to do so? First of all, we have to say or to mention that CANopen and J1939 can be used in parallel, which means that you can share the same cable, the same medium for those. The only thing you have to keep in mind is that CANopen, which is using the classical base frame format, has higher priority than the classic extended frame format, which is used by J1939. And of course, your bus utilization must be calculated in advance. Beside that, also Holger just mentioned it in the presentation before, we have solutions for that within the CiA. There's a truck gateway profile for cranes, hook loaders, and aerial working platforms available, which gives you the possibility to map information from and to J1939 to CANopen. And there is an addition in the CiA 815 standard defines gateway classes with PDO mappings, because the original CiA 413 defines no PDO mappings. What you have to keep in mind, not all signals, not all SPNs from J1939 are mapped. So if you're, again here, if you want to use these kinds of solution and you're missing something, please contact the CiA and we can provide a solution for you. The CiA 413...
Can I ask a question?
Yes, please.
You mentioned that you can share J1939 and CANopen on the same bus or the same network here. Does this also apply when it's CANopen safety and the J1939-76 safety protocol? Or are there special considerations to be taken when using those on the same bus?
I think special considerations have been taken concerning bus utilization. Because what happens is, does it work in principle? Yes. Because J1939 also for their implementation of their safety implementation, they're using 29-bit identifiers. But they have pretty much the same approach like CANopen safety, which means they have 2 messages which have a certain cycle time and which need to have a certain distance between those 2 messages. Mm-hmm. So if you have not well calculated your bus utilization, I would say CANopen safety wins, and the J1939 safety solution will crash because the 11-bit identifiers get through.
Okay, that's clear. But if you take care of the utilization, there's nothing prohibiting the use of both on the same.
No. They're totally, that is what people sometimes missing is that if you're telling me I'm running the identifier 1 on the bus, I will always ask which one, number 1, because the number 1 exists 2 times. It exists as an 11-bit and it exists like as a 29-bit value. So for the CAN controller, for the whole application running behind that they're totally different identifiers and it's totally different stuff.
Yeah, but you should pay attention that the J939 device is not supporting the 11-bit identifier for proprietary purposes. Otherwise, there might be conflicts between the IDs from CanOpen and from the proprietary range.
Could have, yeah, but normally you can use it if you stick to the standard. You don't have a problem.
All right, thank you.
Welcome. Here's one example taken from the CiA 413 specification, multiple body controller system example, where you can see on top I've got this in-vehicle network, typically J939 with cabin display, engine controller, gearbox and things like that. And we use a truck gateway to get down to different kind of body controllers, which have then again their own CanOpen or maybe even a proprietary network. So there are different kind of system designs are possible. Just take a look in this 413 specification. And here is just one example for the mapping. So if you want to get the engine speed rate, on the CanOpen side, you can see the speed value, you can see the maximum speed value and the minimum speed value. And you get also information about the resolution and the offset of that signal. So everything is there on the CanOpen side to get access to the J939 bus. There are existing gateway solutions. You don't have to do something on your own. There's also the possibility to use within a device, if we now look on the device's point of view, to use J939 and CanOpen on pretty much the same CanOpen device or CanOpen node, or if you like the expression ECU, take it as an ECU. I take this expression in a similar way. So for some device manufacturers, for them it's easier because they maybe stick to CanOpen, but J939 provides specific PGNs in order to tunnel between J939 and CanOpen. So that makes it quite easy for you to, for example, buy a device which has lots of functionality, which is originally a CanOpen device, but use it in your J939 network. So this tunnel typically looks like this. I've taken a picture here from our API designs from our protocol stacks. So you typically have the CanOpen slave side where you have got an object dictionary and an SDO server. And the standard from J939, the CiA 510 standards, allows you to get access via J939, via standardized PGNs over to the object dictionary of CanOpen, and allows you to get lots of information of, for example, a sensor data or a sensor or actuator, which is not so simple if you're just running J939. So just to keep that for you in mind, if you're looking for sensors which you want to run maybe on both typical systems, on protocols, CanOpen and J939, have a look on those which make it possible to run both protocol at the same time, because since several years there is a standard for that, and that is possible. So my conclusion is, please use J939 only for powertrain purposes. So avoid, whenever possible, proprietary PGNs for J939. use whenever possible CanOpen for machine control, because that can be extended. Gen 39, it's not so easy to extend because you've just seen the number of PGNs is limited. And if possible, avoid proprietary protocols, because keep in mind that those guys who have developed these proprietary protocols, they will really tire sooner or later.